Have you ever watched a space movie where giant explosions shake the screen with deafening booms and roaring spacecraft race past with thunderous engines? While those scenes make for exciting entertainment, they are scientifically inaccurate. In reality, outer space is almost completely silent. No explosions, no engine roars, no crashing sounds, just an endless, eerie silence. But why does space have no sound, and what would astronauts actually hear if they were floating among the stars? To understand the answer, we first need to understand what sound really is. Sound is not simply something we hear. It is actually a vibration that travels through matter in the form of waves. Whenever someone speaks, claps their hands, or plays a musical instrument, tiny vibrations move through the surrounding air until they reach our ears. Our brains then interpret those vibrations as recognizable sounds. The important word here is through. Sound always needs a material to travel through. This material is called a medium. Air is the most common medium on Earth, but sound can also travel through water, metal, wood, glass, and many other solid or liquid materials. In fact, sound travels much faster through solids than through air because the particles are packed much closer together. That is why placing your ear against a railway track allows you to hear an approaching train long before you can hear it through the air. Water is also an excellent conductor of sound. Whales communicate across hundreds of kilometers because sound travels extremely efficiently through the ocean. On Earth, we are constantly surrounded by gases, liquids, and solids that allow sound waves to move freely. Space, however, is completely different. Outer space is often described as a vacuum. A vacuum is an environment containing extremely few particles. Between planets and stars, there are so few atoms that they are separated by enormous distances. Since there are almost no particles to vibrate, sound has nothing to travel through. Even if an enormous explosion occurred nearby, the sound waves would have nowhere to go. The light from the explosion would still travel through space because light does not require a medium, but the sound would never reach your ears. Imagine standing just a few hundred meters away from a gigantic exploding spacecraft. In a Hollywood movie, the blast would produce an enormous roar. In real life, you would see the brilliant flash of light, flying debris, and expanding fireball, but you would hear absolutely nothing. The silence would feel almost impossible to believe. Astronauts living aboard spacecraft experience this strange reality every day. Outside their spacecraft, space itself remains silent. Inside the spacecraft, however, things are very different. Astronauts constantly hear the hum of ventilation systems, cooling fans, computers, pumps, air circulation equipment, and scientific instruments. Without these systems, they could not survive. The International Space Station is actually much noisier inside than many people expect. Continuous mechanical sounds fill the station because life support equipment must operate 24 hours a day. When astronauts perform spacewalks outside the station, that constant background noise suddenly disappears. Once outside, they hear no sounds coming from space itself. Instead, they only hear noises transmitted through their spacesuit. Their own breathing becomes clearly audible. Their heartbeat may be noticeable during physically demanding work. The sound of air flowing through the helmet can also be heard. If they accidentally strike their helmet or grab a metal structure connected directly to their suit, vibrations can travel through the solid materials into their ears. But none of these sounds are traveling through outer space. They are traveling through the suit itself. Even two astronauts floating only a few meters apart cannot hear each other by shouting. Their voices simply cannot cross the vacuum between them. Instead, they rely entirely on radio communication. Radio waves travel through space because they are a form of electromagnetic radiation, just like visible light. Tiny microphones inside each helmet capture the astronauts' voices and convert them into radio signals. Those signals travel across space almost instantly before being converted back into sound inside the other astronaut's helmet. Without radios, spacewalks would become nearly impossible. Many people wonder whether planets themselves make sounds. The surprising answer is both yes and no. Planets, stars, and magnetic fields generate various forms of vibrations and electromagnetic waves. However, these are not sounds that human ears can hear directly. Scientists use specialized instruments to detect these signals and convert them into audible frequencies. The haunting sounds sometimes released by space agencies are actually scientific data translated into audio. They are not recordings made by microphones floating in space. This process, called sonification, allows researchers to better understand invisible cosmic activity. In reality, if you could somehow remove your helmet while floating safely in space, which is impossible, you would hear nothing at all. The universe would appear breathtakingly beautiful yet completely silent. That silence is one of the most fascinating differences between life on Earth and life beyond our atmosphere. Although our universe is filled with unimaginably powerful explosions, violent collisions, and rapidly moving objects, almost all of it unfolds in complete silence because there is simply no air to carry the sound. Although space is almost completely silent, scientists have discovered that certain regions of the universe contain enough particles for sound-like pressure waves to exist. For example, enormous clouds of hot gas surrounding galaxy clusters can carry vibrations across vast distances. These waves are not sounds humans could naturally hear because their frequencies are far below the range of human hearing. By converting these vibrations into audible frequencies, scientists can create fascinating audio representations of cosmic events. One famous example comes from the Perseus galaxy cluster, where researchers detected gigantic pressure waves moving through hot gas. After processing the data, the resulting sound became known as one of the deepest notes ever detected in the universe. Even though no astronaut could actually hear it, the discovery helped scientists better understand the behavior of enormous galaxy clusters. Stars can also produce vibrations deep within their interiors. Our own sun constantly shakes because powerful waves move through its hot plasma. Scientists study these vibrations using a technique called helioseismology, allowing them to explore the sun's internal structure without physically entering it. Other stars throughout the galaxy vibrate in similar ways like enormous musical instruments. These tiny oscillations reveal important information about a star's size, temperature, age, chemical composition, and internal layers. Black holes do not produce sound in the traditional sense either, but the violent activity surrounding them creates enormous amounts of detectable energy. Gas and dust spiraling toward a black hole become incredibly hot before disappearing beyond the event horizon. Astronomers observe this radiation using powerful telescopes and sometimes convert the collected data into sound for scientific analysis. Neutron stars also generate incredibly regular signals as they spin hundreds of times every second. These pulses can be transformed into rhythmic beats that allow researchers to study some of the densest objects in the universe. This process of translating scientific measurements into audio is known as sonification. Rather than recording actual sound, computers convert invisible cosmic data into frequencies humans can hear. This technique helps scientists identify patterns that might otherwise remain hidden within enormous datasets. Despite these fascinating discoveries, everyday outer space remains almost perfectly silent. Imagine watching two giant asteroids collide millions of kilometers away. You would witness an enormous explosion of rock, dust, and glowing debris spreading across space. The impact would release incredible amounts of energy. Yet despite the spectacular visual display, not a single sound would reach your ears. The silence would make the collision feel even more surreal than the explosion itself. The same principle applies to supernovas, the violent deaths of massive stars. When a giant star exhausts its nuclear fuel, it explodes with more energy than billions of suns combined. The flash of light can briefly outshine an entire galaxy. But across the vacuum of space, that unimaginably powerful explosion happens in complete silence. Even spacecraft launches from the moon would appear strangely quiet to an outside observer. Without an atmosphere surrounding the rocket, its engines could not send sound waves through space. You would only see brilliant flames and clouds of exhaust expanding silently into the darkness. This scientific reality often surprises people because Hollywood movies usually include dramatic sound effects. Roaring engines, booming explosions, and crashing spacecraft make action scenes feel more exciting for audiences. If movies portrayed space with complete scientific accuracy, many scenes would contain nothing but silence. Some filmmakers have embraced this realism. Movies like Asterisk 2001, A Space Odyssey Asterisk became famous for using long periods of silence during space scenes, creating an atmosphere that many scientists praised for its accuracy. The silence of space is one of the reasons astronauts often describe it as both beautiful and unsettling. Looking through the window of a spacecraft, they see glowing planets, distant stars, and endless galaxies stretching into infinity. Yet they hear no wind, no thunder, no birds, and no echoes. Only the quiet hum of life support systems reminds them they are alive inside a tiny artificial environment. This silence creates a profound sense of isolation unlike anything experienced on Earth. Every breath depends on technology. Every conversation depends on radio communication. Every sound exists only because it is generated inside a spacecraft or spacesuit. Beyond those protective walls lies an endless universe where sound simply cannot travel. Ironically, Earth's atmosphere gives our planet one of its greatest gifts. Because air surrounds us, we can enjoy music, laughter, conversations, ocean waves, birds singing, thunderstorms, and countless other sounds that define everyday life. Without an atmosphere, even the loudest explosion would become completely silent. The universe is filled with unimaginable energy, violent collisions, exploding stars, and objects moving faster than anything on Earth. Yet almost all of these extraordinary events unfold in absolute silence. That silence reminds us just how unique and precious our planet truly is. The next time you gaze into the night sky, remember that beyond our atmosphere lies a universe more peaceful and quieter than anything most people could ever imagine. Space may contain countless mysteries waiting to be discovered, but perhaps its most fascinating characteristic is that the greatest cosmic events in existence happen without making a single sound.